July 27, 1944. Near Saint-Diligast, Normandy, France, the 88mm shell sliced through the Sherman's hull with a piercing metallic scream that promised a fiery grave for the 5 souls trapped inside. A Panther gunner of the formidable 2nd SS Panzer Division, Das Reich, peered through his optics, anticipating the familiar, violent blossom of flame that always confirmed a kill. Target eliminated. The driver nudged the Panther forward 20 meters, seeking a superior angle on the next American tank, yet the anticipated inferno never ignited. Instead, the Sherman's turret began to rotate, its 76mm gun swinging towards them, hungry for retribution. The German loader, his hands already closing around another shell, paused, a wave of disbelief washing over him. By every law of armored combat he understood, that American tank should be a raging funeral pyre. Every training manual, every brutal lesson learned from the Eastern Front to the sands of Africa, every scrap of intelligence screamed that it should be so. What the Panther's crew was witnessing on that summer morning was a paradigm shift in tank warfare, a revolution the German war machine had utterly failed to notice. The M4A3, 76W Sherman they had just engaged was armed with a Wet-Stowage ammunition system, a network of double-walled storage bins cradling 38 gallons of fire-suppressant liquid, silently negating the catastrophic ammunition fires German tankers had relied upon as a tactical certainty since 1942. This single, ingenious modification, integrated into every Sherman rolling off the production lines after January 1944, had slashed the probability of a post-penetration fire from a terrifying 60 to 80% down to a mere 10 to 15%. Across the verdant, blood-soaked Norman countryside that morning, the 2nd Armored Division was on the offensive with 104 of these resilient Shermans. Not a single German intelligence report, not one briefing from the Waffenamt, not even a whispered rumor from the front lines had alerted German tank crews that their most fundamental tactical assumption about American armor had just become lethally obsolete. The genesis of this transformation lay in the ashes of a terrible defeat. February 14, 1943, Kasserine Pass, Tunisia. The valley floor was a graveyard of burning American armor. M4 Shermans, turned into instant crematoriums by the lethal accuracy of German 88mm guns. Out of 300 American tanks committed to the fray, 183 were lost, the majority consumed by raging ammunition fires that incinerated entire crews in seconds. The British Operational Research Section grimly documented that 65% of all knocked-out Shermans burned completely. American studies painted an even bleaker picture, with figures climbing as high as 80% in certain engagements. The Ordnance Department's Tank Automotive Center meticulously analyzed every single knocked-out Sherman in North Africa. Their conclusion was as stark as it was undeniable: ammunition propellant, not gasoline, was the primary culprit behind the infernos. The 70-plus rounds, stored in open racks throughout the fighting compartment, became deadly incendiaries the moment they were touched by hot, penetrating steel fragments. The solution did not come in a flash of brilliance, but through a process of iterative design. A chemical engineer from DuPont, present at a tank board meeting in November 1943, floated an idea: surround the ammunition with liquid. Initial concepts bordered on the absurd, proposing to flood the entire fighting compartment with water or create complex, submarine-like compartments. Yet, through persistent development, the concept was refined into an elegant and practical solution: double-walled ammunition containers, their cavities filled with liquid, strategically positioned in the hull floor, far from the most likely points of impact. By December 1943, the Press Steel Car Company in Pennsylvania was already retooling its assembly lines. The very first M4A1, 76W rolled off the production line on January 3, 1944. The W, in its designation, stood for Wet, a simple letter whose profound significance was understood by few outside the factory walls. Testing at Aberdeen Proving Ground validated the new system beyond all expectations. In controlled, live-fire tests, technicians hammered the ammunition bins with captured German 75mm and 88mm guns. The old, dry storage systems detonated in a staggering 73% of hits. The new Wet-Stowage, by contrast, burned in only 15% of cases. Films of these tests, classified until 1963, showed the dramatic difference: dry ammunition erupting in towering pillars of flame, while the Wet-Stowage bins merely emitted small puffs of smoke, quickly snuffed out by the spreading, protective liquid. The modification was a masterpiece of comprehensive engineering. Each ammunition bin was composed of concentric, double-walled cells, each holding 10 rounds, with the space between the walls filled initially with water, then a water glycol mixture, and finally a specialized solution dubbed amudamp. The chemistry was a critical piece of the puzzle. Pure water would freeze in the European winter. Glycols solved the freezing problem but introduced corrosion. Amudamp, a carefully balanced blend of ethyl sodium potassium phosphate, solved both issues while simultaneously enhancing the fire suppressant properties. The M4A3-75W carried 100 rounds in its floor storage, plus 4 ready rounds, all shielded by a total of 37.1 gallons of the protective fluid. The 76mm variants held 71 rounds, protected by 36.6 gallons. While the system added 900 pounds to the tank's weight, the dramatic improvement in crew survivability was a trade-off eagerly accepted. By April 1944, 130 M4A1-76W Shermans had arrived in England. The 2nd and 3rd Armored Divisions each received 52 of these new tanks, although their initial deployment was held back. Concerns about training crews on the new 76mm gun and the logistics of its ammunition supply kept them out of the D-Day landings. These improved Shermans would first taste combat during Operation Cobra, which commenced on July 25, 1944. Operation Cobra ignited at 0938 hours on July 25, 1944, with the most intense aerial bombardment in the history of tactical support. As the smoke from the carpet bombing began to clear, American armor surged through the breach at St. Lo. At the vanguard were the 2nd and 3rd Armored Divisions, equipped with the first Wet-Stowage Shermans to see combat in Europe. Panzer, though devastated by the bombardment, positioned its surviving Panthers in cunning ambush positions. Captured German after-action reports, seized when Panzer headquarters was overrun, reveal a growing bewilderment regarding the resilience of American tanks. Panthers were achieving clean penetrations on Shermans at optimal ranges, yet a puzzling number of their targets simply continued fighting or withdrew under their own power instead of succumbing to the expected fiery demise. What the German crews didn't know was that they were engaging the M4A3-76W and M4A1-76W Shermans of the 67th and 33rd Armored Regiments. Of the tanks their gunners were confidently reporting as destroyed, many would be back in action within 48 hours after field repairs. Those that did burn had typically sustained hits to the engine compartment. The ammunition protection system was performing precisely as its designers had intended. German defensive strategies, meticulously calculated based on the assumption of high American tank losses, were proving tragically inadequate as the protected Shermans survived at rates that defied all expectations. Counterattacks, launched with the belief that they were striking at weakened American spearheads, were met with a strength and ferocity that was both unanticipated and overwhelming. The engineering behind the system was a testament to exceptional wartime innovation. Each storage bin was constructed from precisely manufactured double-walled containers, with a 1.5-inch gap between the inner and outer shells. These gaps held approximately 0.5 gallons of liquid per 10-round cell. The development process had been remarkably swift by military standards. Initial tests with water-only systems in October 1943 had proven the concept but also revealed its flaws: freezing in cold weather, corrosion of the brass cartridge cases, and bacterial growth in the stagnant water. The addition of ethylene glycols solved the freezing issue but accelerated corrosion. The final solution, amudamp, contained ethyl sodium potassium phosphate, fortified with rust inhibitors and biocides. This advanced mixture remained liquid down to -40 degrees Fahrenheit, prevented corrosion, inhibited bacterial growth, and provided even better fire suppression than pure water. Each tank required an initial filling, followed by periodic checks of the fluid levels through conveniently placed inspection ports. According to Ordnance Department records, the system's effectiveness surpassed even the most optimistic projections. When shell fragments pierced a bin, the liquid would instantly flood the area, drenching any exposed propellant before it could ignite. Even if a small amount of propellant did catch fire, the liquid would prevent it from spreading to the other rounds. With this single modification, tanks that would have been total losses were now merely in need of minor repairs. At the Kummersdorf Proving Ground, German technical intelligence was conducting its own analysis of American armor, using specimens captured in Tunisia long before the advent of Wet-Stowage. Their evaluation focused on M4A1 tanks from the 1st Armored Division, captured at Sidi Bou Zid in February 1943. German technical reports meticulously documented every facet of the Sherman's design, its armor composition, engine performance, transmission characteristics, and crucially its ammunition storage. Intelligence bulletins, distributed to panzer units as gospel, contain detailed diagrams illustrating the placement of ammunition racks in the sponsons, high above the track level, with explicit recommendations to target these areas for maximum destructive effect. This intelligence, disseminated as doctrine to all panzer units, became the standard for German tank crews. Gunnery schools from Putlos to Paderborn drilled students to aim for the Sherman sponsons. Range cards issued to anti-tank units highlighted these vulnerable areas in stark red. This tactical doctrine was so deeply ingrained that even when sponson hits mysteriously stopped producing the expected infernos, crews simply assumed they had missed the ammunition. The timing of this intelligence failure proved catastrophic for the German forces. Their comprehensive analysis of the Sherman was concluded just as American factories began churning out the modified variants. Every subsequent intelligence update continued to reference the older, now obsolete, evaluation as definitive. When frontline units began to report the unusual survivability of the Shermans, staff officers dismissed these accounts as the exaggerations of combat-stressed troops. The transformation of American tank production in early 1944 was a feat of industrial coordination unprecedented in the history of warfare. The Fisher Tank Arsenal in Grand Blanc, Michigan, transitioned from M4A2 to M4A3 production, then seamlessly incorporated the new modifications without ever stopping the production line. Between February 1944 and March 1945, Fisher produced 3,071 M4A3 75W tanks. The whole floors required a complete redesign to accommodate the new ammunition bins below the turret basket. This entailed new stamping dies, modified welding jigs, and altered assembly sequences. The partial turret basket, which replaced the full rotating floor to allow access to the hull ammunition, necessitated a redesign of the entire turret traverse mechanism. Hydraulic lines, electrical cables, and control linkages all had to be rerouted around the new ammunition positions. The Pressed Steel Car Company in Pennsylvania achieved similar production miracles. Starting M4A1 76W production in January 1944, they manufactured 3,426 units through July 1945. They had to integrate the ammunition system with the installation of the new 76mm gun, a larger weapon that required turret modifications, different ammunition, and a complete rebalancing of the tank's weight distribution. By June 1944, American factories were exclusively producing Wet-Stowage variants. The transition had been executed so smoothly that German intelligence, working from year-old captured specimens, remained completely oblivious to the fundamental change that had occurred. The hedgerow country of Normandy became an unintentional, yet brutally effective, testing ground for the modification's success. The bocage terrain forced combat into close quarters, at ranges where German guns could easily penetrate the Sherman's armor. Yet, American tank losses proved to be surprisingly recoverable. The Third Army's maintenance battalions reported recovering and repairing an astonishing 67% of knocked-out Shermans during Operation Cobra. Of the tanks that would have been certain fire losses with the old dry storage system, approximately 70% were returned to service thanks to the new protection. This invisible multiplication of American tank strength confounded German planning at every level. German commanders expressed their mounting frustration in war diaries, writing of American tanks that seemed to possess inexhaustible reserves. Panthers were achieving hits, even penetrations, but they weren't producing permanent kills. American maintenance units were recovering tanks that German crews had confidently written off as destroyed, repairing them, and sending them back into the fight. The mathematical model the German staff relied upon to calculate enemy strength, based on permanent losses from ammunition fires, had ceased to function. Major General Maurice Rose's 3rd Armored Division spearheaded the assault with approximately 200 of the improved Shermans. In 7 days of relentless combat, the division advanced 100 miles, fought dozens of engagements, and maintained its operational momentum despite fierce German counterattacks specifically designed to annihilate American armor. The German response, Operation Luttich, the Mortine counteroffensive, was launched on August 7 with 4 panzer divisions aimed at cutting off the American spearheads. The plan was predicated on the assumption that the American armored units would be exhausted and severely depleted after their rapid advance. German intelligence estimated American tank strength at a mere 60% of their actual numbers, completely missing the recovered and repaired Shermans that the modification had saved. The steadfast stand of the 30th Infantry Division at Mortine, supported by tank battalions equipped with the modified Shermans, shattered the German offensive power. The 743rd Tank Battalion absorbed repeated attacks by SS and Wehrmacht panzer units. Despite suffering numerous penetrations, the battalion maintained its cohesion and combat effectiveness throughout the grueling 6-day battle. The Battle of Aricourt in September 1944 provided history with the clearest and most brutal demonstration of this new reality. When the 113th Panzer Brigade attacked American positions on September 19, they expected to achieve tactical surprise and decimate the American armor through the superiority of German gunnery. The initial German attack achieved numerous hits on the Shermans of the 4th Armored Division. Panthers and Panzer IVs reported multiple penetrations on American tanks at favorable ranges, but the American response defied all expectations. Instead of withdrawing with heavy losses, the 4th Armored counterattacked with an unexpected and overwhelming strength. The statistics tell the tale. The 4th Armored Division suffered 151 Sherman losses during the Aricourt battles, but of these, only 41 were complete write-offs. The remaining 110 were repaired and returned to service, most within a week. German intelligence, counting all 151 as permanent losses, calculated that the 4th Armored should have been rendered combat ineffective. Instead, it maintained its offensive operations throughout the campaign. General Patton's initial skepticism about the 76mm Shermans was completely reversed after Aricourt. The Third Army subsequently accepted only 76mm armed Wet-Stowage variants, recognizing that the combination of improved firepower and enhanced survivability created a superior combat capability. As the autumn of 1944 progressed, second-generation improved Shermans began to enter combat. The M4A38, the Easy 8, incorporated the lessons learned from the battlefield, featuring an improved suspension, wider tracks for better mobility despite the added weight, and refined ammunition storage with better crew access. These tanks began reaching frontline units in October 1944. The specialized assault variant, the M4A3E2 Jumbo, incorporated Wet-Stowage from its initial production run starting in June 1944. With frontal armor reaching 4 inches and turret armor up to 6 inches, the Jumbo could absorb a tremendous amount of punishment. Combined with its ammunition protection, these tanks achieved survival rates that utterly bewildered German observers. By November 1944, the First Army fielded 105 M4A32s across various tank battalions. The Third Army had 90 Jumbos and 6 battalions. These tanks spearheaded assaults on fortified positions, absorbing punishment that would have destroyed entire companies of earlier Shermans. Operation Wacht am Rhein, Germany's last, desperate offensive in the West, launched on December 16, 1944, was based on fatally flawed intelligence about American armored capabilities. German planning assumed that American tank losses would follow the patterns established in 1943. The success of the offensive was entirely dependent on the rapid destruction of American armored reserves. German planners calculated that concentrated panzer attacks would eliminate American tank units piecemeal. These calculations all rested on the assumption of the traditional Sherman vulnerability. When the protected Shermans survived at unexpected rates, the operational timeline collapsed. SS Obersturmbannführer Joachim Pepper's Kampfgruppe, spearheading the 1st SS Panzer Division's attack, encountered this harsh reality near Stemont on December 19. His Panthers achieved numerous penetrations on the Shermans of the 743rd Tank Battalion at close range, yet the American resistance continued, unbroken. In his post-war interrogations, Paper expressed his profound frustration at American tanks that continued to fight after taking hits that should have, by all rights, destroyed them. The 761st Tank Battalion, the African-American Black Panthers, demonstrated these advantages throughout their 183 consecutive days in combat, including the brutal fighting in the Ardennes. Staff Sergeant Reuben Rivers, posthumously awarded the Medal of Honor, exemplified the survivability the new system provided. His tank absorbed 2 direct hits on November 19 that penetrated the hull but failed to ignite the ammunition. Despite his wounds, Rivers continued to fight, his crew surviving hits that would have meant certain death in earlier Sherman models. As 1945 dawned, German forces began to capture intact Wet-Stowage Shermans with increasing frequency. Operation Nordwind resulted in the capture of numerous M4A3, 75W tanks from the 43rd Tank Battalion near Herlisheim. In January, German crews operated these captured vehicles for several days without ever recognizing the significance of the liquid-filled ammunition containers. The Waffenamt's Technical Intelligence Branch had, for all intents and purposes, ceased to function by early 1945. The few technical specialists still working were focused on desperate, wonder weapon projects rather than analyzing enemy equipment. Even if the frontline troops had recognized the significance of the modification, no mechanism existed to process and disseminate this vital intelligence. The U.S. Army's Operations Research Office, in their post-war study OROT 117, documented the transformation. Pre-modification Shermans burned in 60 to 80% of penetrating hits. The Wet-Stowage variants burned in only 10 to 15% of cases. This reduction invisibly multiplied American armored effectiveness. A tank battalion with 50 Shermans, suffering 30 penetrating hits, would have lost 18 to 24 tanks to fire with dry storage. With wet stowage, only 3 to 5 would burn, leaving 25 to 27 reparable. The battalion could maintain its combat effectiveness instead of requiring a complete and lengthy reconstitution. Across the European theater, this mathematical advantage accumulated, creating a strategic impact of immense proportions. Conservative estimates suggest the modification prevented the burning of at least 1,000 tanks, which represents 5,000 trained crew members saved and dozens of battalions maintaining their combat effectiveness. German planning never incorporated these new realities. Every single operational plan continued to use obsolete data about Sherman vulnerability. This systematic error, repeated across thousands of individual engagements, contributed directly to the German defeat. Post-war interrogations and memoirs confirm this glaring intelligence gap. Not a single German account from the war years mentions any recognition of this modification. Otto Carius, who destroyed over 150 enemy tanks, wrote extensively about his combat experiences against Shermans in Tigers in the Mud, without ever mentioning any unusual fire resistance. Ernst Bachmann's account of his famous stand never mentions any surprise at Sherman's surviving hits. Unit histories, compiled by veteran associations, provide further evidence. The histories of Panzer Lehr, the 2nd SS Panzer, and the 116th Panzer Division contain no recognition of the improved Sherman survivability. These are not official histories, subject to censorship, but the private recollections of comrades in arms. The Wet-Stowage intelligence failure represents one of the most complete and consequential intelligence breakdowns in the history of modern warfare. A confluence of factors created this blind spot. The German technical evaluation of Sherman tanks was conducted using specimens captured before the modification even existed. By the time the Wet-Stowage Shermans entered combat, German forces had shifted to defensive operations, with limited opportunities for systematic technical intelligence collection. Organizational dysfunction prevented field observations from ever reaching the analysts. German technical intelligence was fractured between multiple, competing agencies with poor information sharing. Resource constraints meant that captured vehicles were immediately pressed into service rather than being sent for evaluation. Cultural factors, including an overconfidence in German technical superiority, reduced the perceived need for detailed analysis of enemy equipment. The very invisibility of the modification proved to be its greatest asset. It didn't change the Sherman's appearance, it didn't require new tactics, it didn't announce its presence. German intelligence, looking for dramatic and obvious changes, completely missed the subtle but profound revolution that was taking place inside American tanks. The story of the Wet-Stowage system offers enduring lessons. Technical intelligence requires continuous, relentless updating. The enemy you studied yesterday may not be the enemy you face today. Innovations need not be revolutionary to be decisive. Evolutionary improvements that solve specific, critical problems can prove to be far more valuable than dramatic and time-consuming redesigns. For military engineers, the modification exemplifies an effective design philosophy: identify the specific problem, develop a practical solution, and implement it across the entire production line. The modification that can be deployed immediately may well trump the perfect solution that requires years of development. For intelligence services, it serves as a cautionary tale about the dangers of analytical blind spots. The enemy capability that seems impossible may be the very one that proves decisive. In warfare, where information is as vital as ammunition, an intelligence failure can be just as deadly as a mechanical one. The Sherman tank's Wet-Stowage ammunition system reduced the probability of catastrophic fire by 75% and saved the lives of thousands of Allied crewmen. Yet its greatest success was in remaining completely undetected by German forces throughout the crucial final year of World War II. From its introduction in January 1944 through the war's end in May 1945, every major American armored operation employed substantial numbers of the improved Shermans. German forces encountered them from Operation Cobra through the final defense of the Reich, capturing and even operating hundreds of them without ever recognizing their fundamental improvement. American engineers designed the system to save lives, not to deceive their enemies. Yet, its invisibility to German intelligence multiplied its effectiveness beyond all calculation. The modification was a validation of the American design philosophy: practical solutions, implemented quickly, proved superior to the German pursuit of technical perfection. History records the Wet-Stowage system as a crucial technical improvement that helped win the Second World War. More accurately, it should be remembered as the modification that won by remaining hidden, achieving victory through enemy ignorance as much as through American engineering. German tank crews fought the wrong enemy, with obsolete tactics based on faulty assumptions, and they lost. The modification didn't just save American lives, it shortened the war by maintaining American armored strength at levels that accelerated the German defeat. In this hidden advantage, multiplied across 1,000 battles, we find one of World War II's most remarkable yet unknown stories: a simple modification that changed everything, while remaining invisible to those who most needed to see it.